All right. Well, it is 9 o'clock, and so we want to give Shane as much time as possible. So, again, thank you for joining us for this workshop of Stormwater Awareness Week 2024. Shane Scott is principal biologist and owner of SSA Environmental, and he's going to be talking to us this morning about retrofitting culverts to support fish passage. So, Shane, why don't you tell everybody a little bit about yourself, where you're joining us from, and then a little bit about your company, and the hour is all yours.
Excellent. Well, thank you. I appreciate your time. I appreciate the opportunity to share this information with folks. Thank you to the Stormwater Awareness Organization. This seems like a fantastic opportunity. I've seen some of the other presentations. It looks like an excellent resource, and I understand all of these presentations will be saved for future viewing and information. So this is the little blurb I had on my registration, talk about culverts and fish passage today and what we could do at culverts, sort of a kind of a low-tech approach to a big issue here in well around the world. Just real quick by way of uh, kind of organization thing. I do a quick an introduction background, definitions, just so we're working on the same language. As I've learned, when you like we're Corps of Engineers, they have their language, and engineers have their language, and accountants have their language. What's the language of culverts? We'll talk today, and then kind of the magnitude of the problem, focusing on North America, the history of retrofits, and what we've done in the past on culverts to help fish get through. And then current technologies, things we've come up with, some ideas, some pretty exciting projects we're working on, and case histories. I've seen a registration list for this presentation and a lot of engineers, stormwater types. I mean, it seems like it's folks that need answers, or know what questions to ask. I spent the weekend up in Metro Vancouver area in BC working with different stormwater groups on several culvert retrofits and inspections. So it's kind of a new world for me. And then some time for Q&A at the end. If anybody has a clarification question, something short I can respond to, please ask. John will help facilitate that clarification. Longer, more in depth, we can answer at the end of the program, or you'll have my contact information and we can talk about that at the end. So real quick, I'm a damn biologist. I've worked in hydro for 30 years. Um, Puget Sound area, Tacoma Power, and then for the WDF, Washington Fish and Wildlife, was in the director's office on Columbia River Dam hydro policy. And then for the last 20 years, I've represented 100 and some public utilities on every fish and wildlife issue in the Columbia River, the largest hydro system in the world. I've worked on amazing fish passage projects, $100 million juvenile fish collectors, uh, spillway modifications, gate modifications, juvenile bypass systems. I mean, it's been a wonderful career. Very political, kind of lonely at times because I work for the man representing utilities. Um, but I started seeing issues with culverts and learning about the magnitude. And I live on Salmon Creek here in Vancouver, Washington. It's a beautiful corner of the world, and we're supposed to have salmon in Salmon Creek. And there were issues several years ago. There were bad culverts, and there weren't many salmon in Salmon Creek. So, as a personal interest and professional interest, I became more involved with that. So, that kind of what we're talking about today. So, we'll jump right into definitions. And I'm assuming lots of folks understand what culverts are, but I looked at Merriam-Webster, kind of see what they said about it. It's that culvert is a transverse drain. The simple, you could have all kinds of complicated definitions, but this seemed like a good one. And these are just the different types of culverts I'm sure many are familiar with. And I don't have a lot of paragraphs. I like pictures. I like pictures to tell the story. So um, I may zip through some of these slides to get to all the information. But here's the culverts. And then this is a really important one. This was new to me until a few years ago. I was always fish passage. I'm a fish passage biologist, concrete and salmon. That's what our world is. But working outside the Pacific Northwest and working now internationally, this term AOP is our kind of term of art in this fish passage world, and it's aquatic organism passage. So it's not focusing on just salmon, but there's all the other organisms, and you kind of just expand to everything in the creek, all the creepies and crawlers, anadromous, I mean, all the different kind of species here. And I've worked on culvert projects that include all of these species in this picture. Um, Habitat fragmentation, that's really the problem. That's what the issue is culverts cut off habitat. Um, like this little diagram on the right, this is just a dendritic diagram of a stream. But every road, usually, as you've driven anywhere, you have a road right along the side of a river. And every creek crossing, you have a culvert. There's a potential for passage issues at that site. So habitat fragmentation is one. And then success, that's an amazing one. That's really interesting. What is success? So, I mean, I work with, federal ESA regulators down to, not down to, but over to asphalt contractors that are replacing a culvert in Pennsylvania. So it's a wide variety. And kind of in my world, it's expanded EOP opportunity, getting critters past those sites. That's one success. Species reintroduction, that's another measure of success. Reduced, in general, just reduced habitat fragmentation. And one I didn't put down here, but I spent my whole career working with engineers, and I joke that my job is to keep engineers out of jail. They're always building things, they're always going out and do stuff, but it affects the environment often. And my job has been to help minimize that. So maybe a fourth bullet is keep the regulators off your back. So, and then, so this is what I've been working on the last several years, just trying to understand the magnitude of the issues of culverts and its effect on AOP and in North America primarily, but then kind of looking out at the world. There's a wonderful, wonderful groups out there that are collecting culvert information, analyzing culverts. There's the National Aquatic Barrier Inventory, just kind of adds up all the information out there. Every state, jurisdiction, seems like everyone has some kind of list of culverts and then some kind of assessment. But just to give you a reference on just the magnitude of what we're dealing with, this is the National Aquatic Barrier Inventory. And in the Pacific Northwest states, Oregon, Washington, Idaho, there's 775,000 barriers. Only 8% have been analyzed, and only 0.5% have actually been mitigated. So it just, a lot of people are doing a lot of good work. It's just such a huge issue. We know where all of our dams are. We're working on, especially in Columbia River and Pacific Northwest, we spend a lot of time and effort and resources trying to reduce the impacts of those dams. But you have all these culverts, just a mass of culverts. Another area, the Pacific Southwest, 680,000 barriers, and 0.05 have been mitigated. Once again, a ton of money is being spent. There's just so many. It's a death of 1,000 cuts on these critters. They're in the Northeast. 450,000 barriers and 0.03 have been removed or mitigated. A lot of good work going on out there. The problem's just massive. And the thing that really got me involved with culvert passage was a Supreme Court case in Washington State between the state and Native American tribes, primarily in the Puget Sound area, where we had the decision was had to protect the habitat that supports salmon. And the agreement was our Washington State Department of Transportation will replace 400 culverts by 2030 to open up about 90% of blocked habitat blocked by culverts. And this on the picture on the right is Western Washington, kind of Northwest Washington, from say Chehalis up to the Canada border. And these are the culverts that are to be replaced. And it sounds like a great project. I understand completely why we need this. Well, to date, 146 have been corrected. And the current estimate to finish all of them is $7.8 billion. Um, there was a project, three culvert project, just awarded north of Seattle on Interstate 5, our main north-south, $136 million to replace three culverts. Now, what can you and I do with $136 million? It's such an incredible cost. And that's just in the Puget Sound area. That's all borne on the backs of citizens in Washington State. So you look at the cost, you look at the magnitude, and there's got to be something else we can do. There's got to be a better way. Um, right now Washington Department of Fish and Wildlife has a barrier removal board, and they go through. It's a very common grant process where you have your favorite culvert and you compete for the dollars and cents to get it fixed. Well, the 03 to excuse me 23 to 25 project list, you have about $85 million. At that rate, we're never going to get to that 7.8 billion. We're never going to fix all those culverts, and this is a Supreme Court decision that we're bound by. 35 of those projects are just planning, engineering, almost 10 million. 76 projects, 76 million or 67, $76 million to actually out on the ground, removing those barriers. So now let's talk about those damn barriers, damn culverts. This is the kind of world we work in the culvert world. Bridges, bad abutments, water surface drops, eroded culverts, just ugly. So what is the problem? What is the problem with culverts? And it's interesting until you really sit down and take a look at these and think about it. It's pretty obvious. It's all about hydraulics. So you have high water velocities because there's nothing in there to slow down the water, shallow water depth, often steep gradient, and then you have a plunge pool at the lower end of your culvert, and that's when you get to a passage barrier. And it's not always 100% passage barrier. Like Washington Fish and Wildlife has a 33, 66, and 100% barrier rating. So there's ways to, and that's for probably, adult sound mounted. There's certain size. It's a certain criteria we use here in the Northwest. You would have different criteria in different areas of the world for those species of concern. But a kind of a fun King County Fish Passage Program cartoon of kind of what we're dealing with in the culvert world. So now what? There's really two choices. So culvert replacement, which we're doing full speed ahead, is really expensive, and it's the correct thing to do. I mean, it's a permanent fix. And then you have culvert modification or retrofit. And there's different levels of that, different types, and we'll focus more on number two. But I just want to always cheer for replacement, where this is where Washington State Department of Natural Resources, you have two little ugly culverts, shallow water, high velocity, water drops down into a boulder field. There's not much that gets past this. It's pretty ugly. They're on the right. You bridge it. That's a nice looking creek. The channel's able to move back and forth through this distance, and there's a whole world of design on culvert replacement and bridging. It's a whole nother hour talk. But there's a lot of experts, a lot of work on that. I'm just demonstrating some. This is Tualatin Creek down in Oregon, just west of Portland. On the left are two old culverts, not in good condition. On the right, they bridged the whole thing. You just see a different character in that creek. But this is what we're dealing with. Now we're going to focus on we had the good, now the bad, and the ugly. So this is almost an extreme example of a culvert. What we have is, as an engineering wise, it's fantastic. It's very efficient, gets water out of the area very quickly. That also precludes fish passage and AOP in many, many situations. So shallow water, high velocity, and no complexity. And I guess probably should have defined complexity, and I'll give some demonstrations of that here. So this is up in Surrey, BC last weekend, and there's a big baffle installation at a 5-foot culvert right behind me, and I'm looking downstream, and this is a perfect example of what stream complexity is. And in a culvert retrofit, you're trying to recreate that complexity. I mean, you're looking at this, you have all the rocks and the logs and the overhang, you have the pools and the riffles and the depth and the edges and all the critters that live in the stream can take advantage of those habitats for feeding and foraging and resting. Um, so you're trying to do that in your a culvert. And I like this picture. That on the left side is Bonneville Powerhouse One, the first dam on the Columbia River. This fish ladder was built when the dam was completed in 1938, and it just weirs and pools. This is where you take your kids and your grandparents and everyone in the region around here. They go to Bonneville Dam and look at the fish and look at the fish ladder. Go down to the window, and it's a great opportunity. But then that on the right are baffles in a culvert, and this picture kind of just quantifies what we're talking about today is reintroducing that complexity in a culvert. So and so the concept, and I'm still trying to develop this as my elevator speech, is you're trying to mimic the complexity in the culvert that you see above and below a culvert. So say you're in this stream is pretty high gradient, a lot of rocks and riffles. So baffles, you're inside the culvert will be closer together to form more of that complexity. So the aquatic organisms that live in the stream, they have the ability to live there. They have swimming ability and the forage, and they exploit that habitat. They can also exploit that habit, not rearing habitat, but passage and move through. So it's not you're reducing habitat fragmentation. That culvert on the right has the similar complexity. So you're kind of making that culvert disappear in the environment. You're making it part of the environment instead of an engineered structure that just shoots water through. So that's my 2-minute elevator speech, but it's making the culvert disappear. So retrofitting with baffles or weirs, that's what we'll talk about here the rest of the hour. So kind of interesting. I asked ChatGPT, where was the first fish ladder? Come to find out it was Scotland. Once again, the Scots came up with it. 1837, a mill owner came up with it. Just a set of weirs to slow water velocities and create step pools and create complexity of the culvert. And another definition I guess I should have said was expands AOP opportunity. I mentioned that WDFW has a rating like 33% passable for existing culvert. If you were to change, you retrofit that or change it, you would potentially increase that to 66% passable. You're not going to go from 0 to 100, but if 33% of the time your species get through and you expand that to 66% of the time, that's expanding AOP opportunity. So there's different types of baffles. So solid baffles are kind of what were developed back in 1837. This is what you see in fish ladders. This technology you see in channels and culverts, and you see the different materials: metal, wood, concrete, plastic. Um, just a commonly used, but they have issues. They've kind of fell out of purpose. The big issues with solid baffles, they retain debris, reduce hydraulic capacity, they're expensive and difficult to maintain. That picture on the right bottom, Latimer Creek, there in township of Langley, I just took that Tuesday. Beautiful looking culvert, great looking baffles, but it's completely filled up with sediment. So you've reduced hydraulic capacity of your box culvert, and you might as well just have a smooth bottom. There is some roughness there, but it's full of gravel. So because of the issues with solid baffles, they've kind of fallen out of favor in the culvert world. Your culvert plugs, overtops, and you get this failure, which is just a huge problem. Emergency fixes, incredibly expensive. The environmental impacts of sediment being released in the stream. It's not a good thing. So I met a gentleman many years ago down in over in University of Amherst in Massachusetts named Kelly Hughes from New Zealand, an inventor, a lover of the environment, a wonderful man. And he came up with these flexible baffles. And he has one on he put a baffle on a culvert on his property 15 years ago and saw that it formed sort of a fish ladder and developed a company where he's now, I'm his North American partner, and he's working all over the world on developing and testing and installing these flexible baffles. Um, there's similar benefits as the solid baffles. They're the same idea. You're adding complexity to your culvert, but they don't retain debris and they have minimal effect on hydraulic capacity. That's the big difference. Many culverts are undersized, or as things get warmer, we have more rain, culverts become undersized. We'll talk about some of the design factors, but that flexibility is the big difference between the two types of baffles. They're relatively inexpensive, very easy to install. I have high school kids do it all the time. I'll show you some of that work. Um, the material that we use now is it's a santoprene, a non-toxic rubber polymer used for water collection systems. You go out to your car and look at the gasket around your car door or your trunk. That's santoprene. Um, Very resistant to temperatures, crushing, very flexible. Um, and it's another benefit of flexible baffles. It could be a permanent, semi-permanent, where you install it and then 10 years easy it should last. I've got them in North America for 5 years and have never heard of a failure so far. Or a temporary installation where working with like in Wyoming, working with a biologist that they're going to replace some big culverts in 2, 3, 4 years when the budget comes in, but they put baffles in pretty low cost to improve passage for trout while we're waiting for that change. Now, you'd put baffles in like this, you're going to have a periodic inspection process. It's a management decision. New Zealand is 10 years ahead of us. They're installing baffles on a watershed basis and inspecting annually. But while you're inspecting annually, you could teach your biologists or your engineers, you could teach your biologists to look at the baffles and fish passage, but also look at the condition of the structure. And you can report that back to the biologists and then the roading authorities, the DOTs. So you can have eyes on that culvert every 1, 2 years. You hire college kids, young people to go do this. This is why I got into being a biologist, to go out in the field and do fun stuff. But so that's so for the flexible baffles, um, and they're customizable for size and shape. In New Zealand, you're dealing with weaker swimming species, so the installations tend to be smaller, and so critters can get around left and right during summertime low flows. So they have freshwater shrimp, these eels, and a glaxid, a small minnow. That's very common species of interest in New Zealand. And here in North America, I mean, we only have salmon here in the Northwest. You wouldn't think we have anything else. But you expand across North America, especially the East Coast, you have the alewives and shad are a big, important, kind of cornerstone species for food webs. And so in this example, this is Haley Creek, just in Surrey last weekend. These baffles are much larger. As a flow comes up, they bend over in the middle, preserving hydraulic capacity, but the baffles on the left and right still are standing up and providing that baffling effect. That's very similar to a natural stream. As rivers come up, fish tend to move to the edges to get out of the main flow. So you're mimicking that condition in your culvert. And we also have some interesting situations. This one is Ontario box culvert. There's some like a bog turtle. Just learned a new species recently. Pennsylvania down in North Carolina, it's a ESA listed turtle, smallest turtle in North America. They don't like to go through culverts. without gravel. So you bury your culvert and then you put baffles in that, and so you're covered down the middle with gravel. That allows the turtles to move through, but you still have the baffling on the side. And here on the right is a installation down near Portland, Oregon, just an offset design. I mean, nothing's written in stone or concrete, so to speak. I'm always open to those conversations about a new configuration, new size, but what we've kind of come up with is a perpendicular orientation. So you do get that ponding. So your culverts do not go dry and strand, weaker swimming organisms. These are installed very simple, self-tapping and HDPE, CMP, polymer, self-tapping screws. We can go up to like 15 millimeters of metal with these self-tapping screws. They're amazing. And then wedge anchors, um, just pretty common. Home Depot. We recommend 304 stainless in our applications. We're looking at other products all the time, but this is kind of our standard proposal. And this is kind of what it looks like. The fixings every 4 to 6 inches, and then towards the end, would be a flat installation. Sorry, and then on the right is a kind of a spec drawing of what this would look like. And your water flows from left to right. So as the baffle bends over, you can kind of see the logic of that. And they're the bullnose design so you don't get debris underneath that lip, that connection lip. So this was last weekend at a watershed event, Cougar Creek Stream Creepers in Delta. Um, and this is just a demonstration of what the baffle looks like this is a 3 foot corrugated HDPE culvert. So how do we get there? So it's kind of being a geeky biologist, I talk about a prescription for baffles. What do we want to accomplish? So we want to accomplish pools and lower water velocity. So we have some criteria. Adult salmon at times is like 4 feet per second maximum water velocities. Other times it's 1 foot per second water velocity. So we develop a baffle configuration to meet that. AOP criteria, we call it. Um, and so we've developed, and these are all kind of live documents. We're always fixing things. I do a lot of work in Canada, so I'm bilingual on measurements to try to do standard and metric. But you can see on the left is the culvert diameter in feet and millimeters, and then length of the baffle. And in roughly, we try to go 1/3 the circumference of a round culvert. And so this is just kind of our generic starting point for our discussions. This is all my website. And then the gradient, I work with my engineer friends on baffle spacing dependent on gradient. The steeper the gradient, the closer your baffles are spaced to maintain pools in between each baffle, so you don't dry up that habitat or that space. Sorry, between each baffle. Um, and then this is a conversation we're having a lot. The the flexible, and the baffles. What does it take to force them to flatten? And these are numbers we came up with. We can get into them later. Then a Manning's number. Conservatively, we estimate it about the same as it would be for a corrugated culvert. So 0.24 or 0.024 on your Mannings. These are open for discussion. These are just kind of rough estimates we have in our conversation. So, gotta hit the right button. So we can talk about forces and what we think is going to happen, but we started using CFD modeling. This is the last paragraph in my presentation. I like bullets. We use CFD modeling to illustrate what's happening in the culvert, and we've got a library of culvert sizes, flows, and baffle configurations and gradients that illustrate what we see, and we could often compare what we see with this. And so those folks not familiar with CFD modeling, it's just an illustration of the depth and velocity of flow in your culvert in different situations. Blue is slow, red is fast. It's just that simple. So this is I'll give a demonstration of project we did. I'll talk a little more about the specifics, but we had a 12-foot wide, 8-foot tall squash culvert that up in Alaska we were working on, and they needed to fix it and wanted to know what we could do to, Alaska Fish and Game wanted to know what we could do to improve fish passage through this culvert. So we developed a baffle configuration, uh, baffles in the bottom of the culvert with a 1 foot spacing on one side to allow fish to get around. So we could install these things and just look at it, see what happened, or we could do the CFD modeling and actually give a visualization of what we should be seeing. And this is roughly the creation of the model. Every polygon is a calculation, and you put a force on a polygon and it affects forces outside of it. And you can see over here, this little green thing is the baffle. And there's a lot more polygons around that, so you get a more refined estimate of flows. And so you do this for your whole section of culvert, and then you apply forces. And in this case, it'd be a flow and a volume. And you get, so just to demonstrate in this real life, this 12x8 squash culvert, 475 long, 2 flow ranges. And we want to see if we could get a 4 foot per second maximum velocity. And we looked at this with and without baffles. And this is what we get. So these are two outputs. The top is 6 CFS, cubic feet per second, with no baffles. And you see your water velocities red, almost the whole depth, 2 inch depth. Water velocities are 6.6 feet per second. This is before. This is after. On the bottom, you have about an 8-inch velocity, same flows, 8-inch velocity, and your velocity is 3.9 feet per second. That's in general. You can see the difference. It'd be hard to go into a culvert and take one spot measurement and average flow. So we don't like to work with average flow in a culvert. When you retrofit a culvert, you create many more complexities. So there really is no average. This is at 92 CFS. This is 90 percentile flow. And you can see on the left, you're getting 3 meters per second, almost 10 feet per second velocities. On the right, you're getting much lower velocities, and from 6-foot depth up to 20 or 6-inch depth, up to 20-inch depth. And bring you in a little closer. Here you can see the velocity and the patterns of flow with the baffles in place. And this line here is about everything below this is the 1.2 or 4 feet per second, 1.2 meters per second, or 4 feet per second velocity where a fish could swim. And then right behind each baffle, they could set. I have a video. I'm not sure if I could show it, trying to figure all this technology out. This project in Alaska, we have videos of small fish laying right behind that baffle. So it's pretty exciting to see that. And this is just a demonstration of the kind of the hydraulic effect of baffles in a culvert, where this is a 5-foot culvert. These are only 4-inch baffles, but this is the effect of the whole water column, a deeper water column. On the left, no baffles. Your water velocities are 5 feet per second. And on the right, even with those small baffles, you're getting a significant hydraulic effect in that culvert with those baffles, even as they're laying over. So just another one of our library of things to look at. So let's talk about retrofit cases before and after. So this should be familiar. We just looked at this. This is Schoenbark Creek Culvert Rehabilitation in Ketchikan, Alaska. We talked about the target velocities and the length, and so it's 475 feet long. They wanted to add flexi baffles to improve fish passage. Well, the problem with this culvert, it was eroded along the bottom. You can see this damage. And another term I've learned last few years, slip linings, when you put a lining inside an old culvert to repair it. Well, the capacity, this culvert was almost too small. They couldn't reduce the size of the culvert too much because they needed the capacity. So what they decided was to shotcrete the inside of this and fill the bottom to fix these erosions. And I've got a great video, but playing it on Zoom is tough. But you can see how they relined the inside of this and then filled up the bottom of the culvert with the concrete and attached 81 10-foot flexi baffles. The plat cost of that was $35,000 for all the material. And that's the retrofit itself is what's much more expensive. I don't have that cost. But the city got a fixed culvert and they have improved fish passage. And like I said, I could post a video on trout getting around this thing right now. The engineer that worked on this, the videos from the engineer, when they returned water to this, within 2 hours, fish started passing into this culvert. So here's an example of a box culvert at Ferndale, Washington, up near the Canadian border. This is an 8-foot square cast in place box culvert, 100 feet long, still built in the 60s, but in excellent condition, very little spalling. Just a flat, efficient chute, water pushing through this, like chum salmon, pink salmon, maybe some coho in here. Well, it's pretty close to the ocean, maybe a Chinook or two. But the Nooksack River Enhancement Association wanted to install baffles to increase complexity, just improve passage to this culvert. So they installed 8-foot baffles, and it only took them about 4 hours. So you had, people that are, kind of non-professional contractors putting in wedge anchors and installing this. So it took 2 days to cut the briars down to get to this culvert, but once they got in, it was 4 hours to finish this project. And the supply cost was $2,300 for the baffles. So you've improved passage. The velocities through here are not huge. This installation should last for years. Oh, I just had a noise. What was that? This is a project we finished last year. This is up in city of Surrey. In the 50s, engineers designed and built this 500-foot long, 6-foot channel to convey floodwater away from an area in the city of Surrey. Gradient's about 1 to 2%. It varies through, but it's a depth and velocity barrier to everything. There's been no fish past this since the 1950s. There's been surveys, electrofishing. There's eDNA. If you've not looked it up, it's amazing. It's kind of a Quincy technology. You take a water sample, you could look at what DNA is in that water, and you could identify pretty much every organism in that water. It's forensics type stuff, and there's been no salmon above this culvert since the 50s. So we worked with the Salmon Hat Restoration Program student volunteers out of Surrey, the city of Surrey, and taught them how to use a Hilti, taught them how to use a ratchet even, and we installed 60 baffles throughout this culvert. And the installation took about 4, actually going into 5 days, but they were high school kids. It was sunny in August, and a lot of fiddle farting around. But once we got everything in, it looked great. So this is what it looked like afterwards. The project was $18,000 to return fish back to some place we haven't seen them in 70 years. So this is a video of what the culvert looked like at low flow during the summer. Walk through here real quick, but it's the whole 600 yards. There's a bridge, a road crossing above and below this. We've installed the baffles about every. Oh, excellent. And then this was the first rains last October. It was the same section of culvert, and you can see the bridge up there. But this is what you're going for. You're creating that complexity, those rest pools. The velocities in here probably weren't too high to preclude fish. They just couldn't get through that 500 feet. So when we talk about success, I got a call in October from the city that they found a adult, this is kind of an ugly picture, but that's an adult coho salmon, the first salmon that's been in Bonaccord Creek above this barrier for the first time in 70 years. And I worked on fish projects all my career, and this is probably this is my second favorite picture. My favorite picture is this one. This is they did some minnow trapping, and this is actually a naturally produced coho salmon juvenile from this first year's reintroduction. Um, so it's kind of why I do this. You go out and see this. When we work with volunteers, you work with the city, you come up with a plan, you execute it, and you get fish back. It was very, very rewarding. Um, so now we'll talk about here in Washington State. We have a lot of experience with expensive road culverts, culvert replacements, and which, once again, it's the best way to go, but the cost is just staggering. And there's often many situations where you can put in flexible baffles as a temporary fix until that project is completed. Or as a management decision, you put the baffles in, and you'll need to go in and monitor every few years to make sure they're still there and operating. But the magnitude of cost is so different that it kind of almost a simple decision to go in and put these flexible baffles in and improve aquatic organism passage as you're going through your priority list for replacements. So this is King County, Washington, which is the Seattle area, has a great inventory of their culverts, their passability, working with WDFW. Then they have a list of several projects they've estimated replacement costs. And so what I did is I looked at those projects, the replacement costs, and then prescribed what would be a baffle configuration and a cost to put baffles in now. So this is Little Sioux Creek in a very important tributary in King County. This is a 3-foot culvert, 60 feet long, under a two-lane highway each way. And the barrier type, and this is characterized for everything, barrier type is water depth, so low water depth. So estimated to replace with the bridge is $5.8 million. It'll be a great looking project. It'll be the perfect replacement, but $5.8 million with the list of everything we're going through. Oh, excuse me. So I estimated to put 8 3-foot baffles in here would cost $1,300 and take less than 1 day. So it's a concrete culvert, use wedge anchors, and you would improve passage through this culvert, either permanently, but more likely today. And then you could work on, how long does it take to work in a water body with ESA listed fish? I mean, a couple of years for permitting. So another project, this is a larger 9-foot wide squash culvert, 55 feet long, 2.3% slope, and the barrier type categorized by the county and the state as a slope is the barrier water velocity. Well, you could the cost to replace this is 5.3 million. You could fix this for about $9,000, reduce that water velocity, improve passage, and it'd take about a day for three people. One on the hill tee, one holding the baffle, and another person running materials back and forth. And this one, it's much less expensive. Two kind of a shotgun culverts, 2 culverts, 4-foot concrete, another velocity barrier, just water velocity is too high through there. $1.8 million, $1.9 million to replace. And this one would take 2 days because there's lots of baffles. So 34-foot baffles, 20 in each, at $4,700. So those 3 projects I just showed you are relatively close together. You can put the baffles in for just a few $1,000s, inspect them annually to make sure they're still there, but still put them on your replacement schedule. Or if you have a list of 1,000 culverts and this is number 733, and you're never going to get to it, just cost and resources, you have improved passage through this culvert. And this is just kind of what we've I've been working in North America. I think 2018 was the first installation of these flexible baffles by the Johnson Creek Watershed Council in Gresham, Oregon, just east of Portland. They now have three installations, but they were the first in North America. But Alaska, British Columbia, so 15 states, 4 provinces. And Kelly's working in all over Europe, New Zealand, Australia. My biggest customer right now is Pennsylvania DOT. I'm in Washington State, but they developed a program where they're doing culvert maintenance from bridges, concrete bottom bridges, uh, culvert replacement, new culverts. Um, they do something for fish passage, do a retrofit. It's not always flexible baffles, sometimes concrete, sometimes metal. It just depends on the application. But that's so they love their trout in Pennsylvania. And so I guess in summary, finished ahead of time. You guys can get back to your day. Uh, Retrofitting with flexible baffles. I mean, as I mentioned, they're low cost, easy to install, permanent or temporary installations, and it's like I may have mentioned, New Zealand's years ahead of us in North America on culvert management. Like Kelly works with different roading authorities where you go to every culvert in a watershed and you assess it and you do something for AOP. Sometimes it's a sometimes there's a small a 2 foot culvert. You put one little baffle in and then some rope to help creeper crawlers get into that culvert. Other times you put in baffles, but then you do have that annual inspection that looks at both the biological condition and the physical condition. And they're finding they're saving millions of dollars on culvert replacements because they're able to identify problems before they ever pop up as issues for repair. Because repairing something in a planned manner is a lot less expensive than repairing an emergency, collapse on a culvert. And then they're biologically effective for improving AOP. Baffles are an old technology. This is just that it's a better mousetrap with this flexibility. It changes the whole calculation on the value of retrofitting culverts. It gives you an option. And then every biologist for almost 40 years has to put this in their presentation. This is Gary Larson did all kinds of fun fish cartoons, but Norm's spawning service. This is what we're trying to do here in the Northwest. A lot of places is just getting the fish back to where they belong, just exploiting that habitat. And I think there's a we have 6 million identified culverts in the United States now. And I could show you that database is a different group, that National Berry Inventory, but just getting fish back to where they belong.
Wow.
But with
Hey,
that,
Shane, we do have some questions though.
okay.
So let's feed some to you. David asks, is initial and calculated post-install water velocity based on median discharge rates?
It could be. What we've done, like that Alaska example, is the 10% and 90 percentile flows. So what we like to do is when are your animals pass? It could be anything you want. We could look at any flow you want. So we set up the mesh, and then we could apply different flows to that mesh. So if that long way answering your question, it's not a median. It
Okay.
can be. It's whatever is of conservation interest to you.
Mel both comments and ask a question here. In the survey, you had a survey after video. It appeared there could be accelerated scour on the downhill side of the baffle. Any recommendations for armoring or dealing with that scour?
Scour on the downside of the baffle.
And Mel, if you want to unmute and clarify, that'd be fine. I think just from what I observed, you're slowing the velocities down. And
Yeah.
so, if anything, scour should improve. Not that scour can't still occur, but it should be better in the after than before.
Yeah. I mean, what we're seeing, and Kelly Kelly can has example of this. We're actually saying, well, and I have pictures of that Surrey installation below that channel, is the plunge pool is actually filling in because you're slowing down um, sediment transport through your culvert, which just demonstrates you're slowing velocities. I mean, if there's any scour in the culvert, it's not severe because you're in concrete. Yeah, maybe I'm not answering or
Yeah, I
understanding.
think that question was more down gradient
Oh,
scour.
down gradient. Oh,
Yeah.
what we're saying that plunge pools are filling, especially
Okay.
with finer sediment. Yeah.
A kind of related question here. Charlotte asked, do you have any recommendations for improvements with plunges? Less expensive ways to temporarily deal with head cutting, which has left the culvert high and dry.
Yes, and I apologize. I was I told John I was tinkering this presentation this morning. We have a culvert ramp. So picture a kid's slide. It's that simple. Made of HDPE. It floats, and you attach that to the exit of your culvert, and that will work depending on the species you're working with. Salmon with big, powerful burst speeds you're just creating about a foot deep channel below that culvert. And I can provide more information on that. There's my contact info, but but yes, there are some options. Sometimes the jump is just too high. I mean, that's replacement or just right off that culvert. But in New Zealand, they have some really freshwater shrimp and eels. And Kelly puts it's like a conveyor belt material and then rope down that, and it forms it's an analog for roots, so the different critters can kind of crawl up through that and get above that perched culvert. So yes, there are options for different species. Yeah.
Okay, okay. Well, there's several comments about the same thing. You must hire very skinny people to retrofit some of these culverts. And on a serious note, how do you make that very tight spaces work in those retrofits?
Get tough or die. No. So Kelly is a much wiry than I am, and he installed all the time. I spent some time in a 3 foot culvert up in Delta, BC last weekend. I'm a little sore, but yeah, you need to be a little younger and skinnier. But about 3 foot is as small as I'd safely go into. Um, what we're doing with Delta is very interesting. Is the bottom of their culverts are eroded, so we really couldn't get the baffles in correctly. So what we could do, and you can do this on safer culverts you don't want to get into. Well, there's two options. You install baffles before you install your culverts. So you put in a new culvert with baffles in. Second is you take a half section of culvert. So cut a culvert longitudinally, the same size as you're working with. So what they're doing in Delta, they're going to take a 3 foot metal CMP culvert, cut it longitudinally, put the baffles in it, and then slip that into the old culvert. One, you get the baffles in there without, you only need to get in to secure it at each length of culvert section. And the other, you can fix that erosion in the bottom of your culvert. So
Okay.
trust me, it's much easier to work in bigger culverts,
Yeah,
but
yeah.
whatever, there's not an issue with enclosed spaces often. I've had that question, but you're open at both ends, and so you have the air circulation and two escape routes. And Kelly's been doing this over 15 years, and I don't recall any issues. You don't want to be claustrophobic,
Yeah,
definitely,
yeah.
but
Well,
it just you need to be reasonable
all
on.
right. Casey gives us a bit of a testimonial. We installed flexi baffles in 2019, still working well.
Excellent.
And then Dan's asking, are there specific species or life stages, juvenile versus adult, that benefit more from the flexible baffles compared to other solutions? Or are the retrofit solutions used mainly as cost savings?
Well, cost savings is just a benefit. The main that goes back to complexity. Um, if there are juveniles in your stream, there should be able to move through your stream. You should be able to move through the culverts. You're mimicking that complexity. And when I started this, since I'm so salmon focused, I was focusing everything on salmon swim abilities, burst abilities. But Kelly kind of taught me about being more holistic and look at the system. So whatever fish are naturally in the system should be able to get through the culvert, juvenile, uh, adult. And it's not perfect. I mean, these culverts are still really efficient, even with baffles in them. But you should move towards improving AOP. I don't know, a long way of answering it, but like I
Yeah.
said, my contact info. We can continue that conversation.
Well, and I didn't realize until this moment that we have Kelly on the call.
Yes, Kelly's on the
Kelly,
call.
let me why don't you unmute and turn your camera on? You had several comments here. Do you want to add a few things to this discussion? And I see other testimonials about we tried it in Quebec this year. And
Yeah.
Kelly,
I don't know if you
there
can
you
hear me,
are.
John.
All right, great. Let me bring you on.
Hey,
Yeah.
Kelly.
Shane, to be honest, Shane's done a great job, and there's nothing much I could add other than sort of acknowledge it's such a complex subject that any of the tentacles you could speak on at length. Um, and I do want to just pick up on this discussion around bed material. Yes, we love to have bed material in our culverts. If nothing else, it looks great, but intuitively, it's going to help with fish make their way through. And that ties in with a couple of things. The question was asked about um, the sort of the trade-off between hydraulic capacity and retaining bed material. And this is true when we're talking both existing culverts and the design for new culverts, which in New Zealand, and we're probably piggybacking on the US, there's an increasing requirement for culverts to be embedded. We are finding that incredibly challenging, particularly in steep upper country, where they're trying to match the grade as well as retain bed material. And you can imagine that culverts either get blocked or a whole big build-up at the downstream end, or it simply gets scoured out. And so where flexi baffles have found a home in new builds is to help retain bed material, but still be able to shed it in high flood events.
Yeah.
And there's even a term now that we had a job just a week or two ago where they originally were specifying to embed the culvert, but they then changed their mind based on experience to say, no, we will put in flexible baffles as artificial bed material to thereby bring about that complexity that roughness naturally gives a culvert and helps fish through. And the last thing that I want to say for now, unless people do want to ask questions, is people talk about the delay. There was that comment in the British Columbia guidelines about that a structure should not delay fish passage. And that's really been an incredibly energetic discussion, shall we say, argument in that space where you have one camp that take it literally and say that no delay, and they talk about cumulative delays over a number of structures have a negative impact on migration, where in the real world, fish take their time to move upstream. So they'll do a bit here and a bit there. And when we talk about our anadromous fish coming home, not to spawn, but to live out their lives, we're finding if you take traditional fish survey methods to understand how long a fish takes to get through a culvert, and if you have fairly vague measures of success as to, well, how long should they take, you can end up setting something as a less desirable outcome when actually it's fantastic, because the reason there's a delay is because the fish have moved in and are treating it as temporary or permanent habitat. And while that's groovy, it messes with the data. It
Right.
skews the data when you're trying to monitor the effectiveness of the remediation.
So
Two
well,
more quick
actually,
questions.
we're out of time, so we got to go to our next workshop. But I'm going to send a copy of the text to you, Shane, and you have the contact information that you can reach out to people. And but I want to thank both of you, especially you, Shane, for your presentation. Excellent presentation, and it'll be in its recorded format here soon on our website. So thank you to everyone for attending, and we'll see you in the next workshop.